Hello, how's everybody today? We're going to go ahead and get into our chapter 10, module 5, object oriented programming and learning about objects today. Uh, and one of the things that most students find difficult, well, let me just strike that. Most students find learning about object orientation difficult. And it's actually rather simple because when you think about an object, just think about an object, as yes, it's a variable you're creating. So just like we have strings, integers, floats, and different kinds of numbers that you work with, characters, you're going to be creating or basically designing your own variable. Now, what does that variable look like that you're designing? Well, think of it like a box. So let's go to the whiteboard here real quick. Think of it like a box, and let's say that box has data inside of it, but that data is always very simple. It's always either a number, a character. In fact, it's always a number, because all data that we store in a computer is just a sequence of numbers or a clever way of putting numbers together to form a picture, an image. But everything that we do on the computer is a number. So an object is a box with numbers in it. It's really that simple. Now, it's a special box that you give a name. And not only that, but that box has the ability to act upon its numbers. And we're going to talk more about that in a little bit. But just think of an object as a blueprint of a variable that you're designing. It's actually one that you're creating. And we have some special words like instantiation that we use with it. But essentially, it's a box full of numbers. And you're the one that's organizing what kind of numbers you have in that box. And not only that, but what they are called. And not only that, but different actions that can happen on those numbers. And that's what an object is. So let's look at the PowerPoint, and we're going to kind of the PowerPoint isn't. I don't really care for the PowerPoint much on this chapter. One of the main things that I want to get across to you is the idea of composition today. And then because we're breaking this down into two parts, and then we'll cover inheritance and another sequence of videos. So we're going to talk about composition today. It's not even discussed in your book. That's fine, because it's an implicit. You use composition all the time when you're working with objects. But the idea here is why did we need to have objects to begin with? And that's because with your normal procedural programming, where you use functions breaking down things into smaller parts to solve, we ended up finding a problem as we wrote larger and larger code bases or programs or libraries. And that is two issues. Well, let's start with the idea of what spaghetti code is and why we needed objects. So let's go back to the whiteboard and let's talk about this example that I have. Now, let's say that we're building a program that keeps track of time. And in that program, we created an hour variable, a minute variable, and a second variable. And let's say that we wanted to be able to set the time, and maybe that function needed to set the time on some specific hardware that was connected to our program in some way, or maybe we were building a driver for some hardware that represents a clock. And then we would build a function that would contain all that behavior that talks to the hardware, and we would send the hours, the hour, the minute, and the second to that function so that it would set the hour, minute, second of the hardware or whatnot, that we were connecting to, or even if we were just using it to have an hour, minute, and second. So the idea of this is, because this is the way you've been programming the whole time, we would create hour, minute, second in main, and then we would have a function called set time. And why is that a problem? Well, let's actually write the code, and then we'll discuss why spaghetti code is an issue. And we may or may not get too far into the PowerPoints today, but the main idea is, when we finish today, I want you to have an understanding of objects, putting them in different files, having your own object files, and then composition. So those are the two goals that I have from today. So we might fly through some of your PowerPoints, but let's go into your code, and let's actually create a program that sets time. And let's say that we have an hour that we assign, a minute that we assign, and then okay, yeah, I don't like you. Why are you doing this? A minute that we assign, and then, oh my goodness, that autofill is driving me insane. Okay, and then a second. Why am I spelling it all the way out? We don't need to do that. Okay. All right, so I guess we've got some serious autofill issues here with some of my extensions. Hopefully it doesn't drive me too crazy. We're going to get to talking about namespaces as well. So let's lay this out so that I don't forget as we progress. Composition. Composition will come after namespaces. Composition will be our last, and then files, object files. That's where we really need. Object files is where we really need to kind of get into. And then, of course, namespaces, when we start learning more about how an object is created. Okay, so we have an hour, minute, second. And then let's say that we have a function, and let's pretend that maybe it connects to hardware, and let's call it set time. And we have H, M, and S. And then what we do is we set some kind of hardware to the H that we send in. And then we have some kind of minutes that we assign to the S that we send in. Let's pretend that we're setting that from, sending it to some hardware, or setting some hardware like a clock or something like that. And then we got a second that we got S. Okay, so this is the function that we're going to send our hours, minutes, and seconds here to. And we're going to call set time over here. And we're going to send it the hour, the minute, and the second. And let's say that that was something that the user input. And we set the time. And then over here, we set the time in the hardware of the watch. So this is spaghetti code. And why is it spaghetti code? Well, because when we think about this function set time, that does connect to our hardware. And let's just put a little note in here, setting the time on hardware watch. Let's say that that's what this routine does. And it's probably a lot of code that connects with that hardware. So here's the idea. We are creating an hour, minute, and second, and then we send it, that hour, minute, second, to this function. That's where the spaghetti noodle comes in. That's like saying, okay, let me go to the whiteboard here. The set time we can think of as a factory. That's the set time function itself. We can think of as the factory. And it's actually what does the main work of connecting to the hardware and doing all the crazy hardware stuff down here that actually sets the time of that hardware. And then we get from the user the hour, minutes, and second in main, and then we send that information like a spaghetti noodle to the factory. So this set time function we can kind of consider as the factory. And so the idea here is, why are we separating these two actions? Why is the setting the time a totally separate thing than the hours, minutes, and seconds variable inside of main? And why can't those be together so that we don't have a spaghetti noodle? Because I'll tell you what, when you start getting all kinds of different functions and all kinds of variables in main, this stuff goes crazy. It just becomes a whole bunch of spaghetti noodles and a nightmare, especially when you get up beyond 20,000 lines of code or so. That's when the code gets bigger than your comprehension. And that's when you must break it down as much as possible. But still, even when we break it down into functions and normal, the top-down function-based programming, we still are creating spaghetti noodles in our pasta, our spaghetti. It's a nightmare to behold when you get up to 100,000 lines of code, not less than 1,000,000 lines of code. It just becomes horrible. So here's the problem that we had, and this was like in the late, I'm going to say the mid-90s. The mid-90s, early 90s, we, had a lot of new hardware, just like today, always new hardware coming out. And the hardware would come out, and here's the problem with the new hardware that would come out. We would buy the hardware often, and we would not have the software to be able to use the hardware. It hadn't been developed yet. The hardware was getting developed faster than the software could keep up with it. And so a paradigm shift happened in the way we do things, and that's when object-oriented programming came into effect, and that's actually what kind of set off the dot-com bubble in the late 90s was object-oriented programming. It changed the whole playing field. Because why can't we take and this hour, minute, seconds, and this set time function, why can't we take that and make them one thing? Why can't we put them all in the same box so that we're not sending spaghetti noodles all over the place? And that's what objects are. So why can't we create a box and call it watch? That is our object's name, watch. And inside of watch, we have the hour, minute, second, but not only that, but here's the key of object-oriented programming. We can act upon that hour, minute, second with a function. So not only can that box that we call an object hold data, but it can act upon that data. And that's where the change happened. Is because of the very nature of object-oriented programming, being able to put those things together so that we don't have this nightmare of spaghetti code that really crunches down development time to where we can't get the software done in time. And even when we do get the software, it's buggy and works like crud. It's horrible. So when we went to object-oriented programming and we started creating objects to hold the hour, minute, second, and the function that connected to the hardware. In fact, this whole object we would build, and distribute with the hardware. And it would be pre-built to interface with the hardware because the data and the actions on the data and to the hardware are together. And that's where object-oriented programming took off. There's nothing really different. It's still numbers. We're still storing numbers. We're still storing simple data types. So no matter what, whenever you have an object, you either have inside of your object, you have a simple data type, and you have actions that behave on that data type. Or let's say that we had another object called dial or hand. Let's say that we had a hand object that represents the hand of our watch. And that hand, just inside of that hand object, we had a variable called length, so that when we drew the watch on the screen, we would know how long to draw the hand. And so then that hand could also be put in here. And even though that's another object that's composed inside of our watch object, it still itself breaks down to a simple data type, just a number, length. It's just a value that represents how long the hand is. So all the object is a box that can contain simple data types, or other boxes that have simple data types in them. And then that can be, it can get rather complex, but the idea is regardless, everything always comes down to a number. It doesn't matter what it is. It always comes down to a number and an action that happens on that number. And that's all objects are. And the main other thing that we are discussing today is that idea of composition. And I'll give you an example of composition, because we're going to actually build this out. This example that I'm giving you, we're going to build out as our discussion on objects. But here's how this changed things for when in the mid to late 90s and the dot-com bubble. It was now, because we had objects that we would build that were particular, and let's say that the manufacturer or the company that built the hardware would distribute the object that interfaced as a library with that hardware. We now had the ability to create, let me rephrase that. We now could make the software before the hardware was even created. Yeah, we could now build the software before we even, and oftentimes before we could even imagine the hardware. So because it was so organized, and that's the key: organization. No spaghetti code. It's everything is contained in a box, and that box, we open up that box using the name of the box to get to the variables. And the name of this box is called watch, and we'll use the name of the box to get to the variables inside. And then we get into the idea of what's called encapsulation. Because if you're building an object for another programmer, because as far as from this point on, I do not care about, I only want you to show me driving your objects. I want you to reframe things, because you're kind of in the mode of user interface, when you're building objects, you're actually programming for another programmer. You're no longer programming for the end user. You're now programming for another programmer. So when you submit your assignments, they're going to be a little bit different. I only want you to drive the objects. I don't need you to get the hour, minute, and second from the user and then send it to the watch. I just need you to drive it and show me that it works. And so that you can just, hard code those in with literals. And I'll show you an example of that as well. Let's go through the PowerPoint, and then we're going to flesh this out a little bit more in code so that you guys can visualize it some more. I want to get through the PowerPoints and make sure I'm not forgetting anything. We may end up just flashing through this because I've already kind of talked about a lot of it. Object-oriented programming, encapsulation. That's the idea of information hiding. If we are programming this box that contains data for another programmer, we only want to allow that other programmer the data that they need. So information hiding is and making variables private are important. Now, here's the thing about Python. Python, yes, we have a naming convention for making variables private versus public, but guess what? It doesn't matter. Python allows private variables inside of an object to be accessed from outside of its scope. So it's really kind of a waste of time to talk about public versus private variables. We'll still touch on it because it's important to understand object-oriented programming and encapsulation and information hiding, because we only want to allow the user to interact with the data inside of the object through accessors, what we call mutator accessor functions, getters and setters. And we're going to be talking about that as well. So the data attributes are what we're going to encapsulate and hide from the programmer that's using our object. And so that information and that access restriction, even though Python doesn't actually restrict the data, that is what you want to do to protect that information that's in the object so it's easy to use. You want to make it so that if you're programming an object for another programmer, you want to make it so that they can mess up and screw around and make it so that your object is robust and handles for improper use. Obviously, if there's a piece of data, let's say it's an object that flies the airplane. If there's a piece of data in there that if set incorrectly in the object, it crashes the airplane, you're going to want to surround the changing of that data with some if statements to make sure that the user, another programmer, is not setting that data incorrectly to crash that airplane. So that's the idea of data hiding and restricting access to information that's inside of an object, is because it not only is it a safety thing, but it's also a security thing. Even though Python allows you to do it. We won't get into deep on that. This minute, hour, second. Okay, set time, set alarm time, class, instance. Okay, so let's get into some code, and we're going to talk about this instance. So what we're going to do is we're going to start with the definition of an object. Now, I'm going to do this improperly first. And this is just to prove a point, and I don't want you to turn in your assignments this way, but we're going to actually define the object up here inside of our code that has main. When it actually, the object should be defined in its own Py file. And I'm going to actually expect that you guys put your objects in its own Py file. And of course, we're going to do that. But I want to give you an example of kind of what happens behind the scenes, and that will kind of gel what the import statement does in your mind as we progress. I'm going to go ahead and get rid of this, and we're going to define a class. And so to define a class, we're going to start with the class keyword, and we're going to call it watch. And then here's the thing about objects. They always have what's called a constructor. Now, because there is data inside of our watch or our box, we may want to initialize that data when an instance is made of that object. Now, we're going to actually make an instance here shortly in main, but let's go ahead and talk about before we get to the initialize function, let's talk about variables and defining variables. To define a variable inside of your box or your watch, you're going to use that special word self. And the reason being is because in main, when we want to create a watch, we do what's called an instance of. So let's say that I want a watch called my watch. And then I'm going to assign that to an instance of the watch object. Now you notice I'm using parentheses here. This is not like, it's not like a function, but it sort of is. What you're doing is you're saying create a watch, and what goes in the parentheses is what we're going to send to the initializer or the constructor of the watch. But this is creating an instance of the watch. We can have another watch because this is the blueprint of the watch. We can have another watch called my watch, a second watch, my watch 2. And let's say that's equal to a watch instance as well. And so we have two watches, one called my watch and one called my watch 2. Now what's going to be inside of those watches? Well, we want an hour. Now you're saying, oh, Mr. B, why did you do those two underscores there? And I'm going to answer that in a little bit. So let's say that we have a self.hour. Now the problem here is we actually are creating a variable, defining a variable, and assigning it a value. So this is what I call definition code. This is what I call runtime code because it actually does something. So there's a difference between defining an object and doing something in the object. This is runtime code. This is runtime code. This is definition code. This is definition code. This is runtime code. So we define the watch, then we do something with the definition of the hour. And since we are doing something and the definition of the hour are together, we have to do that in that special constructor function. And that special constructor function is always given the same name. And the reason why it has the two underscores in front of it and the two trailing underscores is just to make it so that it does not clash with any code that you write in main. So that means that most people will not begin, and in main will not begin a variable. Let's say that I want to make a variable called init and assign it to 34. Well, then I just created a variable that could possibly not, unless I did this, then it would, I just created a number that would clash with this function. And that's a big no-no. So in Python, since we do not have the way to separate out as well as other languages, namespaces, we don't have namespaces. Python uses an old school technique that actually failed for the use of namespaces. And that's why we put the underscores in front of the variables inside of an object. Now, inside of this constructor function, we have to have it tabbed in, and we define an hour function. Notice we're using self. Self is what defines that it's part of the watch definition. So as long as we say self, we know it's part of a watch, of the watch. So we're saying watch.hour equals 0. Watch dot, so that is what refers to the watch. Because down here in main, we called it my watch, but if you're inside of the watch's code, you don't know it's called my watch. So when we refer to data that's inside the watch, we need to qualify it with that it's part of the watch, but we don't know that its name is my watch because it's just definition. It just defines what it is. So it's kind of like me, and like my arm does not know my name is Josh, but it knows it's part of me. So it's like me.arm, josh.arm. So it's the idea of, something that is part of me doesn't know my name, but you know my name. And main is like you. You're outside of my body. You're outside of the scope of the watch. Now this example is getting way out of hand, but but that's the idea, is main is like you. And you know my name is Josh. I am watch. I know I am. I know my name is watch. Well, let's just say, but my arm doesn't know my name is watch. And let's say that this self hour is my arm. So I say me arm or self arm, self hour equals 0. And that's to tie it in with me, which is the watch or myself. Okay, it's getting a little nutty in here. But that's an example of the self idea, why we use it. It's because we don't know what the watch is called, but we need to refer to the watch as a whole inside of the watch. So how does my arm refer to me as a whole? That's the idea. Okay, guys, this is the init function. Let's finish it, and then I'm going to give you an example of how it works. Okay, so let's do self dot underscore minute. No, actually, we got to actually talk about this underscore some more. We got to talk about namespaces and why we use this underscore. Second. Okay. But before we do that, I've got to take a break. I will come back and talk to you in a little bit. Okay, let's continue on. We're going to take a little side venture into namespaces. Now, however, here I want to be kind of clear on this. Namespaces are not in Python, but they have implemented a measure to deal with the problem of why other languages use namespaces. So let's talk about what that problem is. The issue is that when you're building libraries, and this is what we're doing when we build an object, we're building a library. When you import other libraries with an import statement, so you'll use an import statement to get other libraries, and then in main you will write code such as hour, minute, second. Well, even though we have objects, there was still a problem that we would find when we would have in main names that were also in our libraries. And those names would clash. And they would cause problems, and weird things would happen when the programs would get converted over from, it goes through a whole series of conversions and compilations into all the way down to machine code. And to solve that problem, what they came up with when before namespaces were created for the other languages, what they did is they started developing objects where inside of the object they would put the underscore in front of a variable inside of the object that they were creating, that other programmers would import, so that when they used plain English like hour, minute, and second, it didn't clash with the hour, minute, second in the object. Well, guess what happened? All these young and impressionable people would look at these libraries and see that these libraries created variables that had the underscore, and they said, oh, that's cool. Guess what? When I write my code, I'm going to now put the underscore in front of it. Yeah. So seriously, and so then the problem just continued at the name clashing. And so what solved this problem is we said, okay, screw it. Let's put a whole nother box around our library, and let's call this a namespace. And let's put another name on that. Let's call it the time namespace. And then when you're in main, you have to import watch, and then say something like using time. And so what you would do is you would import the library, and then use the namespace to open the namespace doorway to get into the watch library. And that solved the problem. So we no longer need to do this special underscore thing because other languages implemented this wrapper called a namespace. And you would have to use it with your import statement as two different things, so that we would import the library and then say, I'm using this namespace. Java calls it packages. Other languages call it a namespace. But Python doesn't have that. In fact, Python doesn't even does not have the capability of making these private. So the convention in Python, here's the convention in Python to reproduce this issue. Because Python does not have namespaces, guess what they're using? They say, use an underscore in your object. So they're just going and they're saying, even though it doesn't matter, you don't need the underscore. You can build your object just fine without the underscore. Use the underscore in your object to declare that it's private. And then they say, let's go a little further and let's just say we want to make sure that the name mangling happens with this and there are no issues. Let's put 2 underscores to make darn sure that the 2 underscores makes it protected from the naming issues. And therefore, it's what was referred to as name mangling. Even though everything will work fine without the double scores, other than your specific functions like init and whatnot. But if you have your own variables you declare without those underscores, they'll work just fine. It's not. It's just a handle for the problem of when you create a library in Python and somebody imports it, you want the names of the variables inside of your library to be safe. You don't want it to clash with variables that the user of your library is implementing, such as these guys over here. So you want them to be totally different, and therefore the first underscore says, hey, it's private. That means that you shouldn't directly access it. You should use a function that accesses it. And then the second underscore means you're name mangling it, you're protecting it from use over here, from normal use of your library and name issues happening. And that's all it is. So they just used an old school way of doing things. So it's really kind of silly, but it's funny. Actually, it's hilarious to me that they did that, because Python wasn't built to be object oriented. It's you can consider it object based, just like JavaScript is object based, but it's not truly object oriented. They do workarounds to make it so in their updates of the language. So what we'll do now is let's go back to our code and continue with our example. And we're going to continue with our example with what we call the default constructor or the default initializer. So we've created our watch, our box, and inside our watch we have 3 variables that we're protecting and name mangling, called hour, minute, and second. And yes, you have to declare your variables inside of this init function for your whole watch. This init function will automatically be called when you create an instance of the watch. So it will be called for this call, and it will also be called for that watch instance creation. And let's demonstrate that. So I'm going to set a breakpoint here, and we're going to run through this. We're going to debug it, and I'm going to do a step into so you can see what's happening behind the scenes of this instantiation on line 14. And you'll see that the init function is automatically called so that that watch object can be constructed. That means that the data will be defined and initialized that's inside of that watch box. So here we go, step into. And you see the init function is called. The hour is created, defined, and initialized. The minute is defined and initialized. And the second is defined and initialized. Step into again for this one, for watch 2. Same steps happen. Okay. Now this is, we're going to get into accessors here shortly. But let's also talk about the two. You need to have at least 2 constructors in your objects. You need to have what's called the default constructor that will zero things out. And if you have a string in here, self dot, and let's call it the str time, the string version of time, you would just assign it to nothing, empty double quotes. It would be a stringified version of your hour, minute, second, all put together for easy output to the file or to the console when you print it. So this is what we call the default constructor. Now we also need to have what's called an overloaded or constructor. And that is a constructor where you pass the data in that you want to be assigned on object instantiation. Because what if I want to send the watch the hour, minute, and seconds when I instantiate the watch? What if I want to send it that data so that it assigns it to the data I send it from main? And so with that, what we'll do is we'll continue on. The init function that's overloaded still has to have that self. And in fact, every function that belongs to the watch needs to start or have this self in it. You guys, you'll get an error. I do it all the time. I forget to put the self in. When you tie a function to the object, you have to have the self in it. It has to be, it's like saying my arm is part of me. So then we say, well, what is passed to this function from main? Well, we want to pass the hour, the minute, and the second. And you see already our name mangling is coming into handy because we are putting hour, minute, and second here when we have an hour, minute, and second here inside of the object that it would automatically collide with. So what we want to do is we want to say the hour that's in our object is assigned to the hour that we pass it. The minute in our object is assigned the minute that we pass it. And the second in our object is assigned to the second we pass it. And the stringified version of hour, minute, second is the str version of hour plus a colon plus the string of, we want to stringify it. We want to convert it to a string, then put the colon in. Then we want to do str of minute. Then we want to add another colon because we're just basically building a string that represents our hour numbers and seconds variables that are numbers, just to make it easy to print to the screen. So I say minute, the string, let's add our colon, and then we're going to add our second, the stringified version of our second. Okay, now let's run this. I'm going to create a MyWatch3 that implements the overloaded constructor. You can still use the default constructor, but the hour, minute, and second will not be filled up for MyWatch or MyWatch2. The hour, minute, second will be filled up for MyWatch3 is equal to watch. Now what happens here is it pops up. You see the pop-up here. Now it says, oh, we can send any hour, any minute, any second. So we're going to send for the hour, we're going to send 12, 20, 12, 12, 20. All right. So we've done some issues here that we shouldn't have done. And what that is whenever we are assigning our data from an outside source, from main, that's suspect. That means that somebody's using our object and it could get really screwy with it. What if I just put -12 there? No, what if that's flying a plane and crashes the plane? So what I need to do is I need to create some error handling and some input validation for my object. So wherever I have an outside set, anything that sets the data that I am encapsulating and protecting inside my object, I want to look at that data and make sure that it's correct. If the hour that we're sending is greater than 0 or hour is less than 13. That should work. That's the only time that we want to allow hour to be changed. Else, and this is where we want to actually throw an exception so that it can be caught by somebody outside. And we want to throw the exception and say, hey, you did not set hour correctly. And so what I'm going to do is I'm just going to throw, this is where you would throw an object exception, but we're just going to throw a string. So I'm going to say throw, I think this will work, throw error hour incorrect. Let's see if that'll actually work. No, I'm going to have to come back to that and look up again how to do throwing an error in Python. Let's just do this. We should be throwing the hour. I want to throw it. You silly goose. Python, let's do this. Python throw error. Let's see what I'm doing wrong. Oh, okay. Yeah, I'm thinking in the wrong. So you actually use a specific object that's already created for you. So I'm going to do a syntax error. There's different types of errors you can throw. This one will actually be a value error. Value error. And then what I'm going to do is say here, what is the value error? Hour incorrect. Okay. So let's do this. Let's throw this. Let's do a try catch now that we're doing this properly. Try. Okay, we're going to try our instantiations. And then we're going to catch a value error. And then what we're going to do is I think I need to look up how to catch a value error. Oh, yeah. What I'm in the wrong programming language mind frame. Value error, exception value error as E. There we go. Okay, then we just print E. Okay? So let's look at what happens if I try to set the hour to -12. Okay, so I'm going to try to set the hour to -12 here. So I'm just going to set the breakpoint here. I'm going to run and debug. Oh, it looks like I've got a few other things that I've got to fix up here. Oh, that's right. You know what, guys? This actually can't be done in Python. I forgot. That's a default. That's an example of a default constructor, and this is an example of an overloaded constructor. But guess what? In Python, you can only have one or the other. But that's okay. That's what this type of stuff is for. Is to go through that and learn those things or remember them. So let's go ahead and do just the overloaded constructor, one or the other, not both of them. And let's continue on with the example. So you will have either a default constructor or an overloaded constructor. I would prefer you guys always having an overloaded constructor. Okay, now we're going to step into, all right, there we go. Self.hour. Why did that not reach? If hour is greater than 0 or, and. You guys are probably laughing at me. It's got to be and. Okay. Let's try that again. Okay, I'm going to step into. We're going to step over here. There we go. Now we hit our exception. It looks like I need to do something to close that. Did it or to throw it properly. You know what? And I'm going to look into a few other things. But when we come back, we're going to actually have this working, and we'll talk about exactly what I did wrong when I threw this error, because essentially the catch didn't work. So we'll see. I will be back shortly, guys. Okay, we're back. So I made a mistake right here. The way we throw an error is we got to use the raise keyword. Raise value error, and then we've got to put in the parentheses what was incorrect about it. Okay? And then I'm going to show you how to do a default constructor in Python. You actually put them together as one. All right. Let's test this error checking on our watch. Okay, step into. Okay, step over. Our -12 should hit raise value error, and then it should throw our flow. It should throw our top-down behavior out to here. And so these should all be skipped. Boom. There it is. Okay, so then we print what is wrong. And what is wrong is hour is incorrect. Okay, so this is the proper way that you set up an init function. That's part of it, data encapsulation. It's your job to make sure that the data inside of your object is protected. Even though Python allows you to directly access the hour and the watch from main, we should still follow through with those rules, because it's just good practice for an object. And that's just the way it is. So let's look at how to do default constructor in Python. And what we'll do is we actually set these guys to none. None is a special keyword, meaning you do not have to pass it. If you don't pass it, so I can what I can do now here is create a watch. My watch 1 equals watch with an empty constructor, with an empty set of parentheses. Now that I have hour equals none, minutes equals none, second is equal none. It's going to mess this guy up, so we'll fix that here shortly. So let's go ahead and run that. Okay, so you see we have an issue here, and that is hour is having an issue because it's none. So we have to put another if here. If hour does not equal none. If hour does not equal none, then we check the value. Else, if it doesn't equal none, else we need to set hour equal to 0. And that's how you do the default constructor. Yeah, a lot of nightmarish behavior just to have proper data encapsulation and creating the code like you should. Protect the data. That's your whole goal when you're creating an object, is protect the data inside the object, encapsulate it, hide it, and not only that, but add functions to work upon it. Now, we're going to get more into that shortly when we add mutators, accessors, getters, and setters. But I want to show you the actual proper way you should set up an object, and that is implement default constructor behavior and overloaded constructor behavior. And then check the data inside. Now let's get into filling this out, because it looks like we can just take this code and copy paste it, because there's a lot here and I just don't want to redo all this code for every variable in here. When I can just take the same stuff and rename it. So let's say second here, and if second is greater than seconds is greater than or equal to 0 and less than or equal to 60. Yeah, it could be 60, I think. Yeah. Okay. I'm not going to mess around too much on that. Then we allow the second to be changed of the object. Else, oh, I messed up here. Look at that. I said hour. That should be self.hour. And if we are doing this right, oh, you know what? We can actually make this simpler. We can actually just assign it, but you know, I'm not going to get down the rabbit hole too much. Let's just get this in there and move ahead. You've seen an example. There's different ways of doing this to handle for different behaviors from the user. This is going to be self dot underscore second. But you can see how complex this gets. Just really quick, in no time. So this is second that's passed in. If it's not equal to none, and the second that they're trying to set, oh wait, no, this would be, we already did second, this would be minute. Minute. And if minute is greater than 0 and minute is less than 60. And I think it could be greater than or equal to 0 because we got a fence post there. I could have some of the, you know, I'm not going to, yeah, let's move on. Okay, so then I'm going to set minute equal to the minute passed in. And then let's say here, second, incorrect, minute, incorrect, self dot minute equals 0 if they pass nothing. And then regardless, we always set the string time based on, because one of these, regardless of what happens, self.hour is going to be set. Regardless of what happens, self.second is going to be set. That needs to be second. And minute, regardless of what happens, minute should be set. And then we set the stringified version of hour, minute, and second. Oh my goodness, we just got through the constructor. And look at how much of a nightmare we got. Okay, that's fine. Fine. It gets big. But you see, all of a sudden, this is getting to be a nightmarish huge thing. And then we're mixing main in with it. Oh my goodness. This stuff should be separated. We should separate this. We're going to. Let's get there soon. But let's play around with this and just test it. Let's do, let's test this. And you know what? We're just going to run it with different versions. Okay, minute incorrect. Good, it worked. Okay, let's test this one. Let's look at what happens here. Step into this one. Okay, hour is none. So we just set hour to 0. Second is none. Second to 0. Minute is none. Minute to 0. Then we set that. Okay, then this one is going to throw our error and print our error, minute incorrect. Wonderful. Let's test the next one. Let's do 70 here. Okay, so something happened there. Oh. Look at that. That's because I messed that up, didn't I? Yep. It can just, you got to test it, and it can just get just pretty hairy there. No, that's got to be less than 60. Because it goes to 59, then 0. 59, then 0. Okay. All right, now we should have an error being thrown. Boom, second incorrect. Hours, minutes, seconds. Okay. Okay, now let's do this. Even though string time is private, we've declared it private. Let's look at how we access data from main. We have to use the name watch3 dot underscore str time. We should not be able to do that. In other languages, they don't allow that. But in Python, they do allow it, even though it shouldn't be allowed. But that's okay, because remember, Python is loosely object-oriented. Oh, good. They fixed it. They fixed it. Nice. Okay, good. Thank you. Thank you. I'm glad that you guys updated that. Hey, everything kind of continues up. All right. So, oh, maybe I need to, no, that's a string. Let's look at that and see if I can look at this inside of the debugging console. Let's go to our watch here. Okay, so see, it's right there, but it looks like print does not have access to it, even though it is a string. And they threw an error because watch doesn't have one because it's private. Awesome. I am so glad they fixed that. Finally. All right, so the underscores properly allow for private variables. So that means then, well, how do I get the ability to output string time from main, the stringified version of the time? How do I get that ability? And it takes us right into the next thing that we're going to be talking about. That is done through getters and setters. So we are going to have functions inside of our object that can act upon our object. And the reason for them is so that we can get inside of the object and allow access to our private variables. Our private variables that Python correctly now limits access to from main. And we have to give access to those private variables inside or to main or to an outside scope. So what we're going to do is we're going to make this so that I have access to it. And the way we do that is through what's called a getter function. And for every data type that you have inside of your object, you need to have a getter and a setter. If it's a data type that you don't want to allow to be set, so we are not allowing str time to be set. That will only be set inside of our object when we allow a change to hour, minute, and second. So now what we'll do is we will add a function to set or to get str time. And this is our first getter function. So I'm going to say def get str time. And all this is going to do is return the private variable. And now remember, if we are tying this to our object, it has to be self. And a get function traditionally has no arguments being passed to it, except for if it's in a function or an object, you have to tie the function to the object by this self argument. And then we return the watches, the watches str version of the time. Because this function, since it's inside of the object, it has access to the private variable. And that's what encapsulation is for. And then that allows the person that is outside of our object access to str time in a protected way. So, but they have to now change this, is they have to say, I want to go to watch 3's function called get str time, and I want to run that. And what it's going to do is it's just going to return the time. And then that's what's going to be printed. So let's set our breakpoint here. Okay, now what I'm going to do is I'm going to do a step into so that we can see what's going on behind the scenes here. So what happens first is my watch 3, it goes and it gets the data that's inside of string time that was set from in our constructor based on the hours, minutes, and seconds that was passed to it, even if it was passed nothing. Okay, so then I'm going to step into, and it goes in there. We look at str time. See, it's got the 12:40 in there, and that's what's returned, and then that's what's printed down here. See right there, our 12:40. Now we can do my watch 1 here, and we'll get 000 because we didn't send anything. We're using the default constructor or the default behavior of the constructor. And so you see right here we got none, none. It looks like maybe the 000 didn't get changed correctly. So there may have been an issue there with this guy actually being assigned. So we would have to actually fix that. And I would put probably some other information down here. So I'm not going to get too deep into that. It looks like I would have to modify a few other things. We are moving on to accessors. I think that for some reason this guy isn't tripping. And you know what we can do is we could just set a breakpoint to see if that's actually happening. Oh, you know why? I know why. Because I'm using hour. So let's fix that. This needs to be self dot underscore hour. This needs to be self dot underscore minute. Yeah, it gets complex. It gets to be a nightmare. That's why we are being controlled and having things separated. And we do things a certain way. Okay, now we should get our 000 because these else statements are setting our internal memory to 0 like it should when we send no argument for something. Okay. Then we run this. And what we should get is, for my watch 1, we should get 000. Okay, well, we got a few issues here. You know what? Let's do this. Let's move on. And what I'll do is I'll fix this a little bit later and we'll come back to it. Because I really want to cover the getters and setters. Something's going on here with this else statement that's not behaving correctly. I probably need to modify that a bit. But let's get on to our getters and setters, and then we'll make a modification and then discuss it. So we have our get string, and now what we need is we need a get hour, a get second, and a get minute. So that's what you need for every piece of data inside of our object to have access to it from inside. So I'm just going to grab all these guys. You know what? For some reason, there we go. Let's do this. Let's do this. Let's copy this all the way across. There we go. There we go. Nope. Okay, we need 4 total for all the data inside of the object. Okay, so now what we're going to do is this is going to be get hour. And we return the self hour. We're going to call this get minute. We return self minute. And then get second. We return self second. Okay, so we have a get operation for every private variable that's inside of our object. So now I can go to my watch 1, or let's do my watch 3, and get the minute and print it. We are going to comment that out for now because I believe this is a problem for when we're doing this guy. And we'll fix that shortly. Probably towards the end of the video. No, we are fixing it now. But that's okay. It's break time. When I come back, I'm going to have this all fixed up and we'll talk about it, possibly. But then we're going to demo all the other get functions, and then we're going to create some mutators and demo the mutators for our watch object. And then we're going to separate our watch object into its own file, because this is getting to be a nightmare. Look at all this stuff. Oh my goodness. Okay, I'll see you guys soon. Okay, first off, let's get to the fix. And this is a perfect example of how not to do our, especially when you're implementing a default constructor and an overloaded constructor as one. Because if you do it this way, self._our, because they are based on conditionals, and this line is both defining and initializing it, they're not guaranteed to exist. So when you get down here, it says, oh, you're trying to use self.our, and guess what? It hasn't been guaranteed to exist. So what we should be doing is directly creating those variables and assigning to them to 0 first. Then we look at our inputs. We directly create them, assign them first. Then we look at our inputs, and from our inputs, after we've assigned and created, so basically this is like creating the variable first, defining it first and initializing it. And we want to actually make sure they exist before we even start looking or working with them, with any of the arguments that are coming in. And then we can look at the arguments that have been set in and decide what the internal memory of the hour should be set to based on the hours that have been sent in. And that way it handles all the problems for the default constructor. It allows this to be set properly without yelling at you. And that's this is the proper example of doing it. Hey, you get kind of moving in one direction, and of course you always come back and realize, oh, whoops. That's very common in programming. So now that we've fixed this issue, we are guaranteeing our variables that we are putting inside of our object. The other one that I'm forgetting to do is this one as well. This one, before I even assign it anything, I should be actually defining it and assigning it to nothing as well. So that's the way, even if you're doing a default overloaded constructor, always define and initialize your internal variables for your object first, and then start playing around with your arguments and allowing for default arguments. So now when I create a watch, this actually an empty watch. Let's see if this actually works appropriately. Set a breakpoint, run and debug. Okay, step into. Okay, good. Okay, there. Okay, now, okay, so I've got an error to fix there, but when I come back, I'm going to actually get that and figure out what's going on there. For some reason, string time is having a problem with those conversions. So this is the next fix, and let's go play around and figure out what's going on with this. And then I'm going to show you how you can mess around with those default arguments to have different behaviors, and then we'll go into our mutators. All right, guys. See you soon. Okay. We're back. Look at what I did. That won't work. str.__second. That should be self. That should never have worked at all. Python is very helpful for you, but that should have died every time. So it looks like I was not properly grabbing a hold of my internal memory there. And let's see if we are good now. What we're going to do is I'm going to just run this and see if we still have an error. Self.hour, good. Stringified version, self.minute. So this is where, here's where I would go in with debugging. If I'm having a problem with this, I would clearly just grab this whole thing, this whole example, and you know what? We can take the whole expression, select it, just to find out what's going on with this. Copy it, go over here into my watch, paste it, throw in the expression, and see what it comes out as. And then we would know, oh, look at that. It says it's an attribute error. So there's something going on. So now what I need to do is let's take just one of these values to see where the problem is. Let's add that in there. Okay, guess what? We got more problems. So this is one mechanism that you can use for debugging, is to break this down, because there's something that I evidently did wrong here, and I've got to go research how to properly convert this internal value to its stringified version. That might take a little bit of time, but I wanted to take some initial time to show you kind of where I'm at with this. And what we'll do is we'll come back and play some more. See you guys in a little bit. Okay, so I'm going to actually keep this all in the video because this is an example, a really good example on how to debug. So, and some of the things that can happen as you're getting huge in your code base. What I did to find my problem here is I even broke this down, and I just took this guy, I copied this whole expression of hour, and I put it in here, 0. Then I took and I went into here and I took just this one, minute. And I went and I copied that, and I went over here and I put that expression in there, and it came out as an attribute error. And then I got to thinking, okay, something's wrong with my minute. Something's wrong there. I did something wrong. What happened? And then I go and I look up above and I see that I didn't actually initialize my minute. So this is very typical, and a good example of what can happen when you start getting really large code base, a very large code base. And hey, it's excellent to make these mistakes, and that's one reason why I do these demos, is just so you can see kind of how to navigate through those issues. So now that I've added my watch, found out what I did wrong, let's see if I can actually print the time properly and not have an error. Okay, good. 12, get minute worked. Okay, let's do this. Let's print the stringified version of mywatch1.get string time. Okay, so now remember, mywatch1 is going to run with a default argument, which means that its time is going to be set to 000. And so when I do a print get string time of mywatch1, it should output 000. There it is, 000. It's working great. Okay, now let's get a little crazy. Let's do something fun that might look a little odd, and let's see if it works. Because if I have set up so that I have a default constructor and I can pass 1 or 3 variables or none, what happens when I pass just 2 values? Oh, okay. Let's do this. mywatch1 now is going to be 1 and 3. And that's all we're going to pass it. So what happens? In the little pop-up here, you see how it says minute. It's kind of in blue. But it's grayed out here where it has hour, minute, and second. Well, let's just see what happens. You know, I can't really tell from that. Is it going to work? What does it do? And that's why the debugger is so awesome, because it's the best cheat sheet in the world. It'll tell you what's going to happen. So we're going to step into to see what happens. All right, so let's see what hour is. Hour is 1. Minute is 3. Second is none. So it works from left to right. So that means then it's going to go through here. It's going to set the hour. It's going to set the second, or the minute, but it's not going to do the second. The second's going to be 0. So if we look at it, I think, oh, I didn't run this one yet. Okay, I got to step over, and it should be 130. There it is, 130. Okay, let's get a little more crazy. Let's just do one argument. So then it would be 100. Cool. You know what? I'm good. We don't need to do this. Let's just, oh, there it is, 100. Okay, so yeah, this took totally way too long. We got some really good stuff here though. So we're going to continue on with this video, even though we're getting above an hour, because this is showing you exactly how to set up objects properly. We have our getters for every data piece in here. Now we're going to get to the hard part. That's our setters, because we have responsibilities with our setters. We have to look at what is being sent. We are not going to allow a set time though. Set time, this line of code should only happen when we set hour, minute, or second. So what we're going to have is we're going to have a set hour. Okay, so let's get this in here. Now this is also what we call a mutator. So we're going to say set hour. Now notice I have myself in there as well. And what I want to send it is an hour that I'm going to be setting. Now we already have the code written, and we're not going to be returning anything with a setter. Getters return things, and often do not, and most likely will never have an argument other than self. Setters, you will most likely be only setting one thing, and will have an argument of what you're setting inside of the object. Because we are giving somebody the use of our watch, and we need to control and encapsulate the data inside. We don't want to allow them direct access to hour, minute, second, because we don't want to crash the plane. So we already have a checker up here that will check an error or when somebody sets the hour incorrectly. So we're just going to grab that. We're going to go down here, and we're going to set hour. Okay. And then we got to do this, and then we have our set hour set up. Now let's go ahead and run that. How does that work? Well, let's do this. Let's play with my watch 3. And we're going to set it to 12:12:40, but after it, we're going to say my watch 3 dot, let's mutate the hour. We're going to set the hour to 1. Then we're going to print the time. Okay, we're going to run and debug. Okay, so we have a few issues here. I don't think it actually ran correctly or did what we wanted. Because it's got 12, 12, 40. So let's look at what's going on here. Let's do a step into. We've got our hour. If it's greater than 0 and hour is less than 13, self.hour equals hour. Okay, good. But I forgot something, didn't I? Because right here I'm printing the stringified version of the hour. So if I set the hour, shouldn't I also be setting the read-only property, the stringified time, as well? And the answer is yes. So what we're going to do is we're going to go up and just copy this code that we already got. And we're going to rebuild the string time based on the change. And we will only rebuild the string time, which is a read-only property, if the hour has been successfully changed. And then it will show up properly in our output for the stringified version of the time. And we don't even need to do a step over for that. Okay? Why are you being difficult? Do I just need to save you and run you again? There it is. 1:12:40. Okay? So that's when you mutate a property that you've given write access to. Make sure that you update any of your read-only properties as well. Now what we can do is we can flesh this out once that we have this done. Oh, you know what? We've got some code that we don't really need. Because don't we have set hour created now that has this if checker? Let's go up here. Let's get rid of this. We don't need it. Gone. Because can't we just do this? Self.setHour and pass in the hour that's sent. Oh my goodness, that's so much cleaner. Oh, thank you. I like that. Much better. Okay, let's continue on with this. Now we're having fun. Now we're getting this thing really decked out and foolproof. We're protecting and encapsulating our data, all that good stuff. Let's just grab our set function here, and we're going to modify each of those three. We're going to have three mutators. We're going to say set minute. And then here we're going to send it min. Okay, now let's go up here. And you know what we can do? We can let's just cut this out. Oh wait, that's wrong. That one. Don't mess up, Josh, don't mess up. Okay, then what we do is, let's do this. Self.setMinute and send it min here. Done. Now let's finish up our set minute. Oh, right here. Okay, let's line up our scope. Is that done right? Oh, we don't need this. We got to add those back in up top, though. Okay, so we got our set minute. We don't need anything else other than this. We got to add this in. Set up our scope properly. Okay, now we're going to go up here and let's cut this out And we're going to say self.set second. We haven't even built it yet. Okay, let's go down and build it. We're going to have to add this if statement to here and here so that we handle for the none. Okay. Oh, right here. Okay, so we're going to create our set. I'm just going to type it out this time. Def set second self second. Boom. Grab this. Line up my scope. Good. Good. Oh, one last thing. Okay, those are done. Okay. My mutators are done. My error handling is done correctly. My data protection is done correctly. I have accessors, or I have getters and setters. So guys, I'm expecting a constructor, getters, setters, and one other thing that we'll get to in a little bit. I have my time being modified, my stringified time. I need this if statement for each of these guys. If minute does not equal none, then I can set the minute. And then the same thing with hour. If hour does not equal none, then I can set the hour. And guess what? Since I'm setting my stringified version of the time in each of these functions, I no longer need to do it here, but it's not guaranteed to work with the if condition. So I'm going to go ahead and keep it here, even though I probably could remove it because I have it defaulting here, but this is kind of a little bit more verbose, so I'll just keep it. Okay, that really makes my constructor both a default constructor and an overloaded constructor nice and pretty. And then I have my getters. So I can output this single values of my watch from main. And I have my mutators, my setters, for every data type that I want to have write access to from main. And remember, we're not allowing write access to string time. We're only allowing read access to string time. Okay, so now let's go ahead and do the last step, because I've given you an example of a constructor, getters and setters. The last thing I want to do is I want to show you how to do a special thing where you overload a special property in the object to for the toString method. Most object-oriented languages have a toString method for an object. That means that whenever you need to send the object to file as a string or print the object to the screen as a string, you can use the stringified version of it. And we're going to overload the toString method the way Python does. And we're going to be using some special syntax for that. And, I think it's __str. Let's try it that way first. And then what we can do is we can get rid of this crazy nightmare here where we have to get string time. And why do we have to do that? Why can't we just say print my watch 3? That's the way your dictionaries work, isn't it? That's the way your lists work, your tuples work. Why can't I just say print my watch 3 and have it give me the stringified version? and print it to the screen? And the answer is you can. And that's why by adding a special function. So let's add that special function. And so that we can allow that to happen. And what you do is you add a function in here. I may be wrong with this. No, I think it's right because it's popping up here. Okay, so this is some new juju that I don't like. Let's get rid of that. Okay, and let's just return self.stringified version. The stringified version, str time. And so what happens is when you do a print of the object, it's going to call this function and you return your stringified version of your object, and that's what's printed. It's wonderful. I love it. It works great. And this is what I'm going to expect when you guys build objects. I'm going to expect that you have a constructor. I don't care about the default part of it. Do what your book shows you and tells you to do for any assignment. But I'm showing you how to this is an example of how to properly do a constructor. You need to allow for default arguments and overloaded arguments, or none or partial arguments, and that properly simulates an object-oriented approach in Python, even though it's object-based. Some limitations. But hey, they've made some good updates that we found out today. And then I'm going to expect that you have a stringified version of your object, get functions for your object, set functions for your object. Now, if your assignment specifically tells you what to do on your accessors, I'm going to go with your assignment when I'm doing a grade based on what you return in. But this is what should be done. And then you should also be overloading the str function to return the stringified version of your object so that you can just do a print of your object. And we're going to actually set a breakpoint and examine what happens there. So let's see what happens here. Okay, now I'm going to do a step into, and it's going to call this str function. That's an override, I think it's an override is the proper term. And then it returns the stringified variable that we create every time we do a write operation using a mutator of our function. We rebuild the str time. Okay, then I send that and it's printed. Beautiful. Look at that. Okay, so that's what this line of code does. And now I've given you an example of the proper way of, let's do my watch 1. Then we should have 1, 0, 0. One zero zero zero. 1, 0, 0. Okay. That's the proper way of doing an object. Now you notice something, that I've improperly embedded the object in my main file. That should not be allowed. So the next thing that we're going to do when I come back is we're going to separate out this watch into its own file. I'm going to show you how to import. And then I'm going to show you what composition is. I know we're getting long in the video, but there's so much to go over because this will make the next week's videos a little bit shorter when we discuss inheritance. So I'll be back shortly, guys. Thank you. Okay, we're back. And here's what we're going to do. Let's go ahead and get this properly in its own import file. Now, the reason why I did this improperly is to make this point. When you import another bit of code, It's just like taking the code that's in the other file and taking it, and you say, what we're going to have is we're going to say import from watch file, import watch, import the watch object from the watch file. So you can rename, you can have different names for your object. It's better if it's the same name, because you can just say, when you get a little bit better at importing, you can just say import watch when you get to properly doing your library, which we're not going to get into. You can just do it like the normal libraries where you just say import watch. But for this example, and for the way you guys are going to be doing it, you have to say import the watch import the watch object from the watch file. In one very, we'll see how it goes here. So what we need is to take that code and put it in that watch file, watch.py. So it's just like taking what the contents of that file, when you do this import, copying the code that's inside those contents of that file when you do that import, and just pasting it in. And you notice that it's above main. So if it's defined above main, then main has access to it. And that's why your import statements are always above main. Because it literally is, that's what's happening behind the scenes. Is it just takes the code that's in the file, copies it, and kind of pastes it behind the scenes. So this is what we want to do so that our library is distributable. So that, yeah, we got some pronunciation issues today, evidently. Distributable. So that you can easily share it and move it around, allow other people to use it. And not only that, but this is a nightmare. This is a nightmare to have. I don't want all this junk that is just utility code in my main where I'm using it. Why can't I just have nice and simple, use the watch? I don't care what's going on in the background. I don't care. I just want to use it. And that's the idea of encapsulation and information hiding. You protect the data, you encapsulate it, and you hide it. So that people don't have to mess with it. Because guess what? This watch is like your car. You want to get in and drive the car. You want to use the watch. You don't care about opening the hood or prying the watch open and getting in and messing with the gears. You just want to use it. That's what encapsulation is all about. Information hiding, protection, encapsulation. So what we're going to do is we're going to go to our project folder. This is our project folder. mod5.py is in here because this is where my main is. And I want to import my code into main. So that means that I want to put the py file in the same directory, or you're going to have a nightmare of your import statement with paths, and you don't want to deal with that. We're not going to get into those issues. So I'm going to go ahead here and I'm going to say new text document, and I'm going to call this watch.py. Okay. Then I'm going to open up watch.py and I'm going to paste my code there. There, that big chunk of nightmare. It's all in its own contained file. I don't need to mess with it unless I want to actually change it. I'm going to do a save all here now, because now I'm authoring two files. So Control S saves all. So you're going to have to get in the habit of always, when you modify one file, before you go test it, go over here and do your save all. That way you're not testing a file that you've changed but haven't actually updated. So when you change code over here, you got to save it before the changes will reflect where you're importing it from. So make sure you always remember that when you're working with libraries. If you are modifying the library, save it, then test it in main. Okay, so I'm going to say import watch from watch. Let's see if that works. I think I'm probably doing the import statement watch, or wait, no. I think it's from watch, import watch. From watch, import watch. To do the import statement the way you would normally like just do the import watch, you need to have a few other things tied together for a specific library, and I don't want to get into that. So what we're going to do is we're going to say from the watch file, and it knows to look for watch.py. From the watch file, I want to import the watch object. Okay, let's see if it actually does it. And what we can do is we can set a breakpoint here and step into to see if it goes into the file and goes through all the definition code of that file. So I'm going to go ahead and set my breakpoint there, and then I'm going to do this step into to see if it actually finds the file. Oh, yes! And this is how you can debug your libraries. You just need to make sure that it allows the step into. And if it doesn't, then it'll die. Okay, now it's going to run the main. It's defined the function. So I'm going to step into that, step over, create the watch, boom, 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 go print the watch. Done. We did it. We have our own library that we've created. Let's have fun. Let's talk about composition. Composition, you have been using composition this whole time. This watch object is composed of an hour, a second, and a minute. But when I talk about composition, I'm talking about something a little bit more complicated than that. What if we wanted a hand object? What if this was a graphics library where we have the watch, but we're drawing the hand of the watch to the screen? Then we would need to know the length of the hand. That would be part of the watch. So that's composition. The watch is composed of a hand. And it could be composed of an hour hand and a minute hand. So we can create a hand object to include in our watch object a hand and a minute hand and an hour hand. So yes, we can do class hand here so that we can have our two hands in our watch, but that's improper. That's totally improper. Let's do this right from the get-go. Let's go back to our project folder and let's create a file, a new file that we're going to call hand.py. Okay. Now, remember I talked about every object always, no matter what, comes down to simple numbers. So that means that this watch, even though it's going to be composed of some hands, the hand object can have other objects that it's composed of too. You know, you can have a whole directory tree type structure where you have an object inside of another object inside of another object. And so you have a whole object hierarchy based on composition. Now there's another hierarchy we'll be talking about, and that's inheritance, but that's a whole nother conversation. I want to really touch on composition because your book does a horrible job on it. In fact, it doesn't even talk about it. So what composition is when you have a user-defined data type, an object that we create, a box that's inside of another box. So we're going to have two hand objects inside of our watch. So let's go ahead, and this one I'm going to do very simply. I'm not going to get too into the weeds with this. I'm going to just mock up a real quick, simple, easy hand. We're not going to finish it all the way out. I'm just going to give you, we're going to have one getter and one setter. That's it. We'll have the init, and that's it. So I'm going to say class hand. Wait, am I doing this wrong? I think I'm doing this wrong. Let's look at my watch. No, I'm doing it right. Class hand. Okay. Def init. Okay, def init. And then what we're going to have is I'm going to do the self, of course, we have to have that. But I'm going to have the hand length, because the minute length is bigger or smaller than the second. The hour hand is bigger than the second hand, right? Oh, whatever. One of them's bigger than the other. Okay, so I'm going to say here, I'm just going to have length. That's it. If I spelled it right. Okay. And I'm going to have a self length equals length. And I'm not going to do any magic here. I'm just rough code. And then I'm going to have a def get length. And I'm going to return the length. Then I'm going to have a def set length. And I'm going to, I got to tie both of these to self. And I'm not even going to do any error checking here. I'm just going to straight up pass it through, where I'm going to say self dot underscore length equals length. Okay, let me put my my colons in. And we have our hand object done. I'm not going to get too difficult and crazy on this, because this is just a simple example. Now I'm going to say save all. And I'm going to include hand. I'm going to import the hand inside of watch. So I'm going to use it. Now, here's the thing, is when you import watch, it also is going to import what is imported in watch into your main. So you don't need to do import watch or import hand over here. It's included in here since you're already importing watch. So I've got this hand created. Save it. Let's save it. Okay, so I'm going to say from hand import the hand object. Done. Okay, so then that means that now I'm going to have a hand in here. And you know what I'm going to do is I'm going to hard code this hand so that everything happens in the init function, and then I'm going to output it in the stringified version of our data, just so that we're not getting too crazy on this, because I'm giving you a rough idea of what composition is. So I'm going to say here self dot underscore minute hand equals, this is where we instantiate it. This is where we instantiate it. It's equal to a hand. And don't we override? So we got to send it the hand size. So let's say that it's 10 millimeters for the minute hand. Then I'm going to say self dot underscore hour hand is equal to a hand. And this is where templating and blueprint comes in. And I'm going to say this is 100 millimeters. Oh, that's a little bit disproportional. No, let's do 50. Okay, so we have our minute hand and our hour hand. We are importing our hand. Now let's do this. Now let's test this. We've gone far enough. We need to test. Remember, don't write a whole bunch of code and expect it to work. Let's see if we're getting our imports right. So what we can do is we can do a step into this import, and then it'll immediately go here, because this hand, we have to take this hand before watch can use it. This code has to essentially be pasted above. We have to have knowledge of the hand definition before it can be used in the watch. So we have to import it. And I want to make sure that we are actually importing the hand. And so we can step into that one. So let's go ahead and do that. So let's run a debug and step into these and see that we're properly importing our data. Okay, step into, boom. Okay, now this is the tester. Are we getting to the file? Yes, it worked. We defined our hand. Okay, good. Now let's stop this and let's test the next bit. I'm going to go into watch and let's test the hand instantiation. So we instantiate a minute hand and we instantiate an hour hand. So let's go ahead and run this. Python debugger. Good. Why didn't that work? Let's do a save here. And let's do a save here. Just to make sure. Let's go back here. This breakpoint should trip. This breakpoint should trip, but I ran it from this file. So I need to make sure I hit run a debug from main. So I'm going to go ahead and hit run a debug from main. Boom. We tripped it. Okay. Now we can just test this and do a step into. Boom. Yes. Our length is being set. We are good. I just hit continue, I think, on accident. Let's run this again. Okay, let's do a step over, good. Continue, we're done, and we're good. All right, so it did init because it did the init twice because we actually instantiate. No, it did it 3 times. We instantiate. No, we did it twice because it instantiates 2 watches. Okay, so then let's do this. Let's stringify. Let's add a change to our stringify, where we set the string time. And every time we do that, we should actually have a function called setStrTime here, because this is looking a little bit like it's duplicated a lot, isn't it? This line of code is duplicated a lot. We should actually add a set string time, and then do it from here. But you know what? I'm going to be difficult, and we're going to just add, and just for demonstration purposes, I'm going to add here just an output, and we're going to pretend that we're drawing the minute hand to the screen. So I'm going to go here. I'm going to put the minute hand is, and then I'm going to put here, and I'm going to put do the stringified version of, and here's where we're going to access the hand that's inside the watch. I'm right now inside the watch code. Self.get, I didn't build any accessors, did I? Oh no, did I build an accessor? Yeah, I did. Oh, but you know what? Since I'm inside of watch, I have access. I have direct access to the minute hand. So what I can do is I can actually just say self.minutehand right there. Dot. Now I'm outside of hand. I'm in watch. So I have to use the hand get accessor. Get. And it looks like we're having some issues here with our hand get length. Let's just hard code that and see if it works, because we may have some issues in debugging that we have to do. But it should work. Okay, but it's got this weird thing that means it's having a problem finding it. We might have an issue with that. Let's do this. Let's test this line of code in the constructor, And this is another reason why we should have a set function for this, set str time, because this is going to get nightmarish. But let's set a breakpoint here and let's just test this. In fact, let's make this even easier to test. Let's just do this. Instead of doing all this nightmarish stuff, let's just see if we can access it. Self dot minute hand dot get length. Okay, let's set a breakpoint there and see why that's not working. Oh, I got to run it from over here. Okay. Length is not... Oh! That's the reason why it wasn't working. Is because Python knew that there was an error, so it didn't add it to the definition of the interpreter. So, there, okay. Return self underscore length. All right. Now, when we go over here, let's make sure we save this. Save all, actually. Now, this should work a little bit better. Oh, I got to run it from over here. Jeez, it gets so confusing sometimes when you've got multiple files opening. Okay, now let's do a step into to check this. Okay, good. Length is 10. It looks like it ran. So does that mean that our thing worked? Looks like it. Okay, let's go ahead and let's get rid of this thing. And you know, again, we should have a function that does this because this is going to get silly. This is silly, but this is what we're stuck with because I don't want to put any more time into this already overblown length of a video. But seriously, guys, this stuff takes time. And it takes a lot of time to get through all the main concepts of what an object is and how to properly do it as well. And then, of course, the mistakes that happen along the way and fixing those mistakes and using the debugger. Okay, so we should have now, when we stringify it, we should have the output of the minute hand is. So when I print my watch 1, it should have that output. There it is. And we have absolute total beauty. Okay, guys, to wrap up everything, remember the proper ways of building an object that I demonstrated today, and also all the mess ups that I made along the way, and then how I described what I did to fix it within the debugger. Remember, when you build an object, I'm expecting them to be in separate files and you importing them. I'm expecting you to have the constructor, the init, I'm expecting you to have the stringify function, the toString function, underscore str. I'm expecting you to have getters and setters, and you will only have setters for your writable. You will only have setters for your writable variables, and setters should have limitations set on them for the data that's inside of them. You should have data checking. That's part of your object because you're now programming for another programmer. Okay, now and then, think about the composition that we did. So getters and setters, properly separating out read and write properties, and the getters and setters that are joined. Notice that I do not have a setter for this str time because I'm setting that as a read-only property. So that's why it only has a getter. It only has a get function. That's all it has. And then the last thing. Here's the last thing. I do not want you to ask the user for hours, minutes, seconds, and then put the user's input for hours, minutes, and seconds when you drive your object. This is all I expect. You to drive your object send the data to the object, print the object, show the screenshot of you printing the object. That's all I care about. And then, of course, follow the instructions of your assignment. That's really what I'm going to be doing, basing your grade upon. I would like you to see you properly do your objects like I demonstrated here today. But other than that, guys, we are done. Thank you. Goodbye.